We left off looking at cars in general and started by considering an overview that includes all the cars in our data set, for example. And then we can do mileage per gallon, we can do price, we can do various attributes, including pictures this way. One thing we covered, all the magenta part, the purple, is just maybe showing one of the cars. So it's brushing. There was a little bit of an example of that in the paper that we looked at with the students and missing class, how many absences they have in grades and so forth. Some of it was popping out when you were moving the mouse over. So that was an example. You kind of saw it in action. So it's something popular that shows up. And this slide in particular shows focusing. The idea is that, well, I really want something in the range 12 to 14,000 pounds. And what I can do is maybe use interaction and click on the bar. And that highlights everything. It's not filtering in the sense that it's not taking away elements from the visualization, but it's just it's kind of highlighting. Maybe using brushing to highlight, or maybe using some other technique. So it can actually change the encoding and change the representation. But it still leaves it. If it's using brushing, that you can say it's not changing the representation. I just use brushing for it, which is what this image displayed. But it doesn't have to do that. Next, I could do something more than just one attribute. I have multiple attributes. Maybe I can select something in that price range and the mileage per gallon that I'm interested in. So kind of a very economical car. Well, it's not that economical, I guess. It's 30 miles per gallon rather than 40. And kind of see, I have two cars that satisfy both criteria. So it's like performing queries. It's what I was telling you last time. Instead of going and answering a lot of questions and then seeing the results, here I can see the results while I perform the query. All the results are there. Everything is there. The entire ocean is displayed. And now we're moving from representation, from how to encode stuff, into how to present. What happens if I have a lot of data many times? What's my choice? For example, I could use a scroll bar. It doesn't mean that I changed how my data is encoded. It stays exactly the same. But the scroll bar is part of the presentation, and that would be part of chapter 4 in the book. So they talk about ways of dealing really with large data sets and some maybe complex data, where I don't change how I view the data, but I do have ways to kind of look at a lot of information that way. So that is one way, for example, use a scroll bar, but that's obviously, scroll bar doesn't give me there's hidden information in there. I have to navigate. Maybe a better way would be to use suppression. So what happened here, some of the attributes, the top ones and the bottom ones, that were hidden previously with just a scroll bar, now they're being shown, but they use less visual features. In a way, less ink, less space, something like that. So they kind of, it's suppression of detail, if you want, suppression of graphical, you're kind of, I'm taking away some of the ink or some of the space. Most of the time you want to suppress space. But sometimes you can get away with just doing coloring or transparency stuff. So in this case, I'm suppressing space. But the idea is that I'm using fewer graphical elements, fewer graphical currency, for a better word. I don't know. Space, like I said, most of the time, or color transparency in other situations. But here is space. So the attributes that are on the top are only showing maybe 1 pixel wide. And the ones that I want to look at, they're shown completely and fully. And then I can use this scroll bar here to move the area that's being focused on. So everything is still going to be there, but I can move up and see more of the attributes that are on the top, and I can move down, kind of navigate up and down. And again, this normally is considered part of the presentation, just like scrolling, but in a way, I do come up with a different encoding. So I need to come up with a different encoding that uses less space or fewer colors, or somehow makes the display, makes it possible for me to display more information. So suppression is more of a graphical detail issue. Focusing that we looked at, what I started with, it's more of an emphasis issue. Maybe there's an overlap right there, but this is more of a emphasis of certain data from my database. And here, many times when I talk about suppression, I talk about suppression of graphics. So this is more on the graphical side, on the display side. Now, if I'm really convinced that I don't want to look at everything there, it may be just noise. It becomes noise and distractive, so it can distract me. Then I can do filtering, and that really takes away information that I decide I don't need. So that's another way. I'm not changing how I represent the data, but I'm changing what data, how much data I'm showing. So it's still part of the presentation, not of the encoding. This next one is a little bit weird. I don't have a good name. I don't think the author of the book has a good name for it. They call it sensitivity. And all this does, it's trying to tell you what would happen if I press this bar. So for previously, you don't know what would have happened. What would happen if I press this bar over here? Probably nothing based on what's in there. Do I get more? Right now, I know there's nothing selected from that bar. But do I get more or do I get less? Well, do I get nothing? I'm going to get less. The way this works, because it's an AND, it needs to satisfy the mileage per gallon and the price. And then if I decide to select this one here, it has to satisfy that one as well. So it's going to be less, but is it going to be nothing? Or it's going to give me, at least it's going to reduce and going to leave me with one car that I like? I don't know right now. So that's what the sensitivity information is kind of trying to give you an idea of what will happen if you press on it. So in this case, looking at it, you can kind of see if you include this bar in your search, and that's going to be cars that satisfy this black bar and cars, and if you want to include the yellow bar in your search as well, then you're going to get one more car. How do I know? Well, it's this car here. The fact that it's not filled in, it's just a coding and encoding. I could figure out another way maybe. But the fact that it's not filled in, it tells me it's not included in my search right now. So if nothing would be here on top, so if this would be out of here, that tells me if I click on that bar, I won't get anything new. No new car. And then if I unclick this one, I will get a null, because no new car and unclick and so forth. There's a video that you can watch a little bit later, and it will explain. But they call that sensitivity. So it's basically trying to tell you what would happen in your next step. So one idea people had with visualization is maybe kind of at the beginning was it should allow exploration. If you already know exactly what you want, then a query is your best bet, because you know what you want. Visualization is not going to make it any more. You know, that's it. You want that, you get that. But if you don't know, you want to explore, then you kind of drew it through a number of steps. So the idea here is that sensitivity will tell you what the next step brings. Kind of gives you a cue. Not 100% what you're going to get, but it gives you a cue what you're going to get. Are you going to get nothing? Are you going to get more? Are you going to see no change if you include that? So that's why they have sensitivity in there. Again, I don't have a good way to name this feature. It's just kind of next step.
But shouldn't it be intuitive?
Yes, but here we're talking about a term for it. It is intuitive when you do it. It's kind of explain why, how, when I explain the technical stuff, I don't have a good term for it. It is pretty intuitive. You see, there's one more car there that you're going to get that you don't have yet. And maybe if there was another car here that was filled in, I already have that car. So if I click here, I just get one more car. And if that's not worth, you're looking for 10 more cars, then don't click on it. That's not going to give you the 10 cars or a lot of cars that you're searching. So it's harder for me to explain what it is than to actually do it for a user. So for the most part, here is a diagram from the book, and that's what we do. We kind of take the data, we figure out an encoding, for example, bars, we figure out the size of the bars, everything we talked about marks. How wide are those bars going to be? What colors are they going to have? So we figure out all of this, which they call the representation. It's the encoding. And it's kind of, in the book, it's going to be next chapter, chapter 3. Then once we figure out how to encode that, we can write a program or a visualization. And the program kind of goes through the data and encodes it that way, so we see it. But then we may run into issues what if there's too much data and we can fit it on the screen, or the window is too small. So that's an issue of presenting the visualization. We're not necessarily changing how we're doing it, but we're changing what? The amount that we're showing. We're showing this to a user. There's perception and kind of how we represent stuff, and the user will then the user our brain kicks in, and it's higher learning cognitive stuff that we do, decision making, learning, and so forth. And based on what we see, we might come back and have interactive things to change what we're looking at. Okay, the book and the course, for the most part, we're staying on the left side of this. We don't do much about how people make decisions. If you want a marketing course would be better for that. Marketing, you're trying to change people's decisions, and that's what you're trying. You don't care about the visualization as much as do they buy more of that stuff or not? Can you convince them? So that's more, if you want, that would be an example, or psychology would be more on decision making. We don't do much on the decision making part in this course. Mostly focus on take the data, come up with representations. How do people perceive a very little on how we think about the data. More like, can we solve a problem with it? That's kind of the extent to which, is there a way for us to solve it? Is that an easy way for us to solve it? So that's kind of an overview of the rest of the book, mostly. So in summary, we have the representation and encoding. So we have figured out the overview, detail, sensitivity. How do we represent? We need to figure. Well, in that case, I represented that by not filling in the shape. Just I have the outline of the shape, but not the inside. Brushing. I think the book actually sometimes says that brushing is part of the presentation, but I would think you're changing the encoding. So I would put it here, although I can see an argument where you want to put it in the presentation. Focusing and suppression, they're all, in my mind, change how we represent data. The encoding part. And then you can see suppression is put in both. It depends how you do it. But you can do it on the fly and kind of switch between two representations, one more detailed, the other one less detailed. Filtering is changing the presentation. Panning, and that's changed. Zooming, changing the presentation. I'm not changing the encode, I'm just zooming. I'm making it a little bit bigger. So if I kind of use like a lens, like a graphical zoom, that's not changing how I encode data. And then we have interaction, and we talk about exploration, and sensitivity helps exploration. I want to navigate through the data. And then on human performance, we looked at, we maybe talk a little bit about perception, talk about pre-attentive processing, and then how we interpret sometimes data. Nominal, do I see a pattern? Do I see that data as being a, continuous? Things like extent, is 6 showing up about 3 times as big as 2 or not? or as something, as colorful, as wide. So that's what this is talking about. And really the book, the encoding they use, they actually, somebody built a program, and I met the person. I think he was with Mitsubishi Electric Research Lab, Merle. And they actually, Easy Chooser he came up with this technique to just navigate through the data. They call it for some time, I think originally it was called Easy Chooser, but it went through different names, the way that they were, again, Merle was marketing it under different names. And Easy Chooser, or you'll see it in the video, Verizon for a while wanted to use it as a search engine for people to kind of navigate. Instead of Google, you would use something like this. I think problem is just the querying is too expensive if you want to do it for 1 million users hitting your servers at the same time. But you're going to see it in action, how this works. And it's everything we talked about, but it's just it's an implementation that somebody did. Actually, I think the book was written after this. So this came first. The book just uses that as an example of overview detail brushing, things that we may run into with visualization. Okay, so I will share my screen. Those of you at home on these sharing, especially for watching it recorded, might help to just go straight and kind of copy and paste. You probably get a little bit better quality. So for the most part, this has, if there's a sound, I will not talk during these, so you can kind of watch them in parallel and let the recording flow. Okay, so this is Easy Chooser. And you can see it starts with it has a Verizon logo. It's no longer with Verizon. That was a few years back.
This video will show you some demonstrations of Easy Chooser, a tool developed at Verizon Laboratories to help consumers make choices using the attributes of the choice set. You're looking now at a home page of a site on our intranet where users can upload and import data sets and make use of the tool. We'll start by looking at some examples. And within those examples, we'll try and give you first an idea of how a user might make use of this tool to make a decision. So let's presume that we're making a choice regarding picking a university. What I could do on the web is look at a table like this. This is a table that shows lots of good data about universities in the United States, the top 50 in this case, and there's lots of information. But it's quite difficult to make sense of information in that form. So let's go back and take a look at the Easy Chooser version of that same information. First, you'll notice that each row has a different attribute. So here's overall rank. And by looking through the table like this, I can sort of see, I can browse it. So I can see here actually that Dartmouth is ranked first among these top 50 here. And if I'm making a decision, I'm going to take a look and see what information is here to see what might matter to me. Here, for example, is an attribute that might matter to me personally, the percent of classes under 20. So a user might make a selection such as this to say, let's take a look at only those universities here that have 70% or above of classes under 20. And I've narrowed my selection set down to 9 here. And now, by looking at where these rectangles fall on other attributes, I can see how that set ranks with respect to these other attributes. So here, for example, I can notice that this set also has a pretty high rather low acceptance rate, 10 to 20%. Which may be a little stiff for my decision. So I can also relax that first restriction and go back and see what happens if I look at those that rank in 60% or above with small class size. And I can see that my selectivity and acceptance rate has also relaxed. So I can make further restrictions here. For example, I could say, let's look at only those universities with an acceptance rate of 40% or greater with small class sizes, and I get a set of 7 now. Now for these 7, I'm also able to mark them. For instance, let's take a look at Vanderbilt. I'm going to click here, mark Vanderbilt in red, and now go back and look and see how Vanderbilt falls within this multidimensional context. And let's see it pretty much in the middle of most of the rankings. I can just look at that with a real quick glance. I'm able to actually select up to 3 and color them. So here I'm looking at how Vanderbilt compares to Brandeis across all these different criteria. So with these basic methods, I could narrow my set down, explore the data, and go on from there. Let's take a closer look at the actual techniques we used. And to do that, I'm going to go to another data set. This happens to be the data set that is deployed on superpages.com, which has new car data. I'm going to pick a set of cars called subcompacts, and it's going to load in data about this set. We're going out onto the internet now, so we may have to wait for a moment for the data to load. Here it is. So one of the things I did in that previous exercise was that I swept my mouse along a row of icons, and I was able to explore let's say the extremes, for instance, of that value. So here, for instance, I'm able to see which Chevrolet models are actually in this set of subcompacts, and there are 3 of them. I was also able to mark an item. So, for example, this Chevrolet Cavalier, I could mark it with a color, and then quickly see how that particular item ranked with respect to many different attributes across a larger context. Both these methods make use of the notion of item vectors that we discussed in the paper. Another set of interactions had to do with value selection. So for example, here I might choose 3 values such as consumer guide rating here, best, recommended, and budget buy. And then I might also choose a price range. Let's say I go from $12,000 to $16,000. So now I've done a dynamic query where I've restricted my set just to those that match those values. Note also what happened to the icons above the bars. You can see in some cases the icons are now gone, which indicates that those items have been eliminated from the set. So if I actually clicked a value where there was no icon, I would get no matches. There are also some icons that are drawn but not filled. This is an indication that there are more, if I select those values, that combines them with logical OR and actually adds to my set. So in this way, this is a help to users to guide their queries, and that also by viewing these icons across the dimensions, they can explore the effect of making restrictions and how those restrictions would react with other attributes. So it allows users to explore the information. Let me go back to one last example to discuss some issues with regard to the scale of Easy Chooser. Here I'm going to show you an example of images. In this case, the tool scans the disk and extracts data about all the images on a file system. So here we're looking at actually 546 items in this space. Now, as I restrict my set by selecting and filtering, notice what happens to the display. Now you can see that the rectangles are visible, whereas before they were simply what looked like solid lines. As the set gets smaller, because they're rectangles or perhaps icons drawn here, I'm able to make selections and browse individual items, which makes sense to my task. At the higher scales, I'm able to deal with attribute information to restrict further and explore relationships. And besides what happens with drawing of the items, notice what happens with the actual value bars as I filter. So here, what started out as a choice of ranges between 0 and 500K, 502 megabyte and so forth. Now I'm down to the hundreds of kilobytes in my selections. And as I go further, I recalculate yet again the set of value bins that are relevant to that set size. And in this way, the tool is able to scale across different set sizes in order to make labeling and selection easier for users. So we hope we've given you an idea of Easy Chooser and the techniques it uses for supporting tasks involving object selection based on attributes.
Okay. Talking about US News and World Report, the information science program, the online part of it is kind of, I think, top 20 or top 10, I can't remember. So we just got, I mean, this year, the newest thing, so FYI. Just the online part. Those of you who, I'm kidding, but those of you who are not online, you're not in a good program at all. So, but that's why I'm combining the class, I guess. Maybe it helps. One more thing. I have MPV. If you look under lectures, the author, I talked to him and he was like, okay, I'll give it to you. Unfortunately, it's based on applets, which don't run anymore, but you can on a regular browser, I mean. To run them, you would have to use the applet viewer, kind of see it here. That comes with a Java distribution. So if you get Java Standard Edition, you get an applet viewer, and that you can make it work. So I'm just starting it right now. I hope. I don't know. Oh, I didn't do it right. Okay, I need the HTML. So this is one with the digital cameras in it. You already seen the selection, so I'm not going to spend that much time on what you can do. It's in the video. More on the technical details. Here is the folder. They have a set of images with the digital cameras in them. So you can drop the image in here in a folder, and then the file itself. First of all, there's the HTML file. I'm going to open it up with Notepad++, for example. There is one error. I think you have to fix the error. I think they put a px somewhere on the width, or one of these widths is wrong. And I had to change it. And all of them, Applet View, I mean, a browser doesn't care, but Applet Viewer cares about it. So you can't put px or anything after it if you ever try and do that. So that's warning number one. And then the data itself, let's see if I can open it with, I'm just going to take it to Excel. If it will let me, apparently it won't. It's really comma separated values.
Enable content, probably do after that.
Now maybe import. Oh, they don't have import. So let me select all files. It popped up another thing right here. So it's going to be delimited. I think it's either tab or comma separated. Let's figure out exactly what it is. Next. Tab is comma. So it's a comma separated file with all the attributes, and somewhere in here they have the image URL. if you really want to do it, you know, you can find it's a slightly modified comma separated file. You get the dimensions. So these are probably things that you have to tell Easy Chooser or MPV what to do. Kind of, if you're curious, if you ever want to use it, you could, and that's all the time I'm going to spend on it. But it's right there. So you have to fix. I mean, you have example of HTML, you have example of data, and might as well, if you want to use it for yourself. So that's pretty much the end of this set of slides. I'm not going to go back, I'll just pull it up quickly, but oh, let me finish this. And that's another maybe help. That's my way of trying to help with homework 2. It could help homework as well, but homework 2. 25 ways to visualize a data set. I used to do visualization of a book, but that one also is applet based, so it doesn't work in a browser anymore. But it was an interesting visualization of something like Alice in Wonderland. You can look at the entire book in one screen and navigate through it. So one data set visualized 25 ways. So this looks like, just like the comment at the bottom, looks like spaghetti. It's life expectancy at birth, various countries, years. I think they have life expectancy, year, country, and gender. There's no gender in this representation, but it just looks like spaghetti views. So here's another view of the same thing using small multiples. And then you have each country is one of these little things. So you have all the countries. You kind of see some countries went down. Sometimes you probably look at this one. I don't know. That's not good. Life expectancy going up and down. Wars and things like that would kind of take it down. Here's life expectancy of birth for a single year. And then the countries are ordered, not by alphabetical, but by life expectancy. So the top one, the longest expectancy are at the top, lowest are at the bottom. And it creates this nice shape of the view. Otherwise, it's a bar chart. This shows change over time. And it kind of looks very ragged. There's no sorting, so you can see what sorting does. And I think here you can see change percentage. There's a little bit of animation going on. So it's just change over time. They probably picked 2 years, and they show how it's changed from 1 year to the next. I'm not sure if I can zoom in. It's not doing anything, just it's a dynamic page. Focus on the difference between men and women. Obviously, you probably know that ladies are on the far side, higher life expectancy than men. So you can kind of see it everywhere, but there are countries where the difference is a lot bigger. Again, probably war, but war tends to affect, I don't know why. War tends to affect everyone. And disease. Here is life expectancy for, you can see the difference. If it's really thick, that means there's a big difference between men and women. And then it shows it between the number of years, 20 and 2000 and 2015. You can kind of see the trend. The trend is generally going up, I think, most all over the world. But if it's a thick line, then you have a big difference between genders. If it's a thin line, they're probably about the same. Life expectancy of birth, and here is 2 years. Instead of doing the difference between men and women, they do the difference between 2 different years, 2000 and 2015, what you see. And again, countries that tend to have high expectancy, they tend to have low difference between years. You can see at the bottom, there's a lot more going on. I mean, bigger differences. Comparison between males and females. So what do we have here? You can see a correlation. It's a scatter plot. So one axis shows male life expectancy and the other female. And there is a correlation. I mean, it's almost all in the diagonal. And each dot is one country. So I see all the countries in a dot. So you would look for some outliers, probably things that are here that are on the top means ladies live longer. Men tend to kind of than men on that. So if it's on this side, on the top side of the graph or the bottom side. They're using some lines to connect, they look a little bit fuzzy. So the beginning of one line and the end of one, kind of see where it went. It's still the scatter plot that you have here, but it also shows trajectory over years. I don't know, a little bit fuzzy. Generally going up, I guess. Again, small multiples using lots of little plots for, looks like it's for each country. And you see the difference. It's the same scatter plot, but it's for each country over the years. So what you see is many years in one scatter plot, but then the axes are still men life expectancy versus women life expectancy. This is an animation of the same, with the years now kind of being animated. You can see pretty much there's a big move up, but there's some that still go down. This is percentage change between 2000 and 2015. You can see most of them tend to be kind of the same percentage, but then there's some that go up really high and some that go down. So there's 25 ways. Again, there's many, many, many ways to look at. There aren't that many data attributes in here. So these are your choices. Life expectancy percent change from previous year. So it's like you take this one, but do it instead of having each country's or one line, and you get the spaghetti view, you get the small multiple view where each country is one graph. This is a little bit fancier, focusing only on a handful of countries, so it's not showing everything. Kind of see where things are, percent going down 10% or going up 1%. Life expectancy in a single year, 2015. And you can see there's a dot somewhere in the middle for each country. This is an animation. Everything is animated. Not sure if you can track that many hundreds of things moving. And showing everything in a compact space, but less separation between countries. Not very clear, I would say. Everything seems to be dark, and they're ordered, so you have the darkest. Talking about different spatial substrate, now they're using one of the axes is round, the other is straight. I'm not sure what this brings. Makes it maybe harder to understand. Sometimes circular substrate works, maybe not this time. You can have the year kind of going around the axis. And then life expectancy, I think it's the straight axis. Classic, talk about this in a second. So whisker and plot diagram, or Taki plot. This is a histogram of distributions for different years in country. You can see most countries there's one big distribution here at the top. Or most countries are in the middle. Smooth versions of a histogram, they just smooth it out. You kind of see where the curve is, like a bell curve. I'm not sure how many I covered. I think I've done enough. So there's more. Okay, so we're back. So there's more than one way to skin to solve this problem. You kind of look at them through different angles. You can select years, you can deselect years, or in your case, be days and dates of reporting, regions, and so forth.